ওকে, গুড মর্নিং স্টুডেন্টস। কালকের ক্লাসটা রেকর্ডিং প্রবলেমের জন্য হয়নি আর কি নেওয়া। তা আজকে আমি স্টার্ট করছি। রেকর্ডেড সেশন হবে এটা। তোমরা সবাই দেখে নেবে। আজকে ডে 8 স্পেশালি। ইট ইজ 19th June. Okay, so for this day we have to start the topic called variance inflation factor. Okay, so this is the last topic actually. uh, Before starting the linear regression, you have to read very small two parts, very small two topics, that is regression and lasso regression. This is also important for your upcoming gate exam and any competitive based exam regarding machine learning. Okay, so today I will start. So before starting, so last day I have taught r square, right? You know the r square. And what is the r square formula? Already we have known. Uh, you are known familiar with this formula actually. R square, uh, 1 minus RSS by TSS. So this is basically the r square. Already we have learned. But using this r square, another term is there. Another important term is there. VIF. Okay. So today I will start this VIF. Actually, last day I have missed this one, so that's why I have to start today VIF. And after that, some shrinkage concept you have to read. The shrinkage concept means regression and lasso regression, and regression is most important compared to the lasso regression. So I will do a numerical based on that. So please write some sentence around VIF. Okay. So VIF. So the full form is variance inflation inflation factor. Okay. So this is the full form of VIF. So what is this basically? So VIF is a measure. Please write VIF is a measure used to detect the presence and severity of multicollinearity in regression analysis. Remember, VIF specially is a evolutionary metric also that is used to detect the multicollinearity present or not. So if there are any multicollinearity present, then VIF value tells that. Okay. So what is the formula of VIF? Already I have okay, I have not written right now. So now I am writing. So VIF equals to 1 by 1 minus r square. See, this is the formula. Just imagine, if r square is high, then I have told you the model good. Okay, model is good. So if r square is high, then model is good. So if r square is high, so what is the maximum value of r square? So r square has a maximum value greater than equals to 0 and less than equals to 1, right? So r square has a maximum value 1. So if we put 1 here, then you can see 1 minus 1 minus 1, that is 1 by 0. 1 by 0, that will be infinity. So remember, if r square equals to 1, then VIF equals to infinity. Okay, if r square equals to 1, then VIF equals to infinity. And if r square equals to 0, then see, if r square equals to 0, then VIF equals to 1. So what should be the range of the VIF here? So VIF has a range which is greater than equals to 1 or less than equals to infinity. Okay. So this is the range of VIF, remember, and we have to learn the significance of VIF now. Okay. So first see, multicollinearity is what? Multicollinearity multicollinearity occurs when two or more predictor. What is predictor? Predictor is basically features. Okay, two or more predictors or features in a multiple linear regression. In a multiple regression model are highly correlated, which can cause problem in estimating the coefficients of the regression model. Remember, so multicollinearity happens. Just think about it. Multicollinearity means what? Suppose you have a data set. The data set contains several. Suppose you are predicting the rain prediction. So you are predicting for rain. Okay. So suppose you have a data set. You are predicting the rain. So rain prediction means suppose how much rain will be happen today. So if it is 50 ml, if it is 50 ml millimeter, 50 millimeter, or 10 10 millimeter, or you can say it is 2 or very small or very little rain, and very high rain, 100 millimeter. So you should predict, you should find one model that predicts the rain. Okay. So to predict the rain, suppose you have taken a lots of data, and one data is temperature. Okay. One data is temperature. And there are lots of data. I am not writing. Okay, all. But one of them is temperature. Another is atom. So basically, this is a problem. That's why I am given this example. This is a very common problem for a model of rain prediction. So attempt means actual temperature. So this is the real temperature, real feeling. So this is the temperature we have felt. Suppose this temperature is on in Kolkata is very large, right? Suppose it is around 50 degree. You know, na. In today's situation, the real temperature or real feeling temperature, or you can say it is F temp, feeling temperature, and it is the actual temperature. Actual temperature is how much? Is 38, 39. That's all. But real feel, or the feeling temperature, you can say it is 50 degree. So these two are highly correlated, right? We know. So from the definition of this temperature, feeling temperature or actual temperature, we know. But some of the parameter features we don't have any idea without any analysis. So for that case, you have to find the VIF. So VIF specially used to detect whether any multicollinearity present or not. So these two are highly correlated. I am giving one example just. So if I find the rain prediction model, then this F temp and A temp should be correlated. So what will be the problem? See, think over it. Suppose this rain amount we are predicting using the F temp and A temp. So basically these two are same thing. not the same value but the same notion. Remember, in machine learning, values doesn't matter. The notion is important. Notion means the gradient of the line. Already I have told you na, in the last class I have told you the center data. So for the center data you have seen, suppose some data are present here. Okay, so if I make them center, then you can find the same data points will be converted into, suppose, 1, 2, 3, 4, 5, 6, 7, 8. See, the same notion, you can find the same pattern here, but here also you can find the same pattern. The pattern remains same, but only what? Only this data set is converted or present around the center. Okay, these data set are present around the center. So this is the concept of centered data. So that's why these data values are not important. See, the values are different. For the first point, you are taking the value, suppose x value is this one and y value is this one. But here you are taking the first point, x value is this one and y value is this one. Values are different, but see, the notion of the data remains same. So this is called the notion of the data. Okay, this is called the notion of the data set. Okay, notion of the data set. Okay, so multicollinearity means if any two or more features are correlated, that is, from the definition or from the notion of the data they are correlated, then there will be a problem for estimating the coefficient of that particular features. So this is the concept already we have seen. The multicollinearity is a problem. So to detect the multicollinearity we are using basically VIF. Okay, so now tell me, if VIF is equals to infinity, which one? Which should be better? VIF, high VIF or low VIF? See, I am just discussing here. So if VIF equals to 1, just think about it. If VIF equals to 1, that means R square equals to 0. The model gets confused to the find the exact coefficient of the features. Okay, if VIF equals to infinity, that means R square equals to 1, the model fits well. The model fits well without any multicollinearity in the data set. Okay. Okay. So remember, R square is 1 is the best model. Similarly, VIF equals to infinity is the best model. Okay. R square and VIF both should be high, and high means actually infinity is not possible in practice, and that is R square equals to 1 is also not possible in practice, but near to 1 is a desire. That is VIF near to infinity, very high value is desired. Okay. Okay, so this is the concept for VIF. So now I think you can find one numerical. So suppose the last numerical I have. So okay, so I am giving one numerical problem number one. Calculate the VIF. Okay, just to calculate the VIF. So find the VIF of the model having equation y equals to 0.2 x plus 2. 0.2 x plus 2. So this is a model. Okay, this is the model, it is given. So you have to predict, you have to find the VIF using the given data set. So the data set is also given. So this y is basically actual, okay, and this y is basically predictor. Remember always, model have a value y, which is basically the predicting model or predicting value, and this data set contains the actual y. Okay, suppose 1, 2, 3, 4. So it is 1.5, it is 2.3, it is 2.6, and it is 2.9. Okay, so this is the, okay, actually it is 2.9, sorry, it is 2.9. Okay, the first one is 2.9, I mistakenly it 1.9, sorry. So this is the question, you have to find the VIF. So this type of question will definitely ask in exam. Okay, it is a very common question. So VIF equals to this one. So sorry, this is a model, this is the model, and this is the given data set. You have to find the VIF. So how to find the VIF? See, so to calculate the VIF, you have to find the table first. X, YP, YA, residual, residual square. Okay, so you have to first fill this table. So 1, 2, 3, 4 it is given, and 1 point not predict. Okay, so for predicting, okay, so 0.2 x plus 2. Okay, this is the formula. So if I put 1 here, so it will be 2.2. See, if I put x equals to 1 to find this predicting value, so you have to put the x value in that particular model. So if I put 1, then it will be 2.2. It is 2.2. If I put 2, if I put 2, then it will be 2.4. If I put 3, then it is 2.6. If it is 4, then it is 2.8. And actual value is 1.9. Second one is 2 point, how much I have forgot. 2.3, 2.6, 2.9. Okay, 2.3, 2.6, 2.9. And what is the residual? Okay, residual is predicting minus actual. Predicting minus actual, so it is 0.3, it is 0.1, it is exactly 0. Okay, and it is minus 0.1. So if I make them square, 0.3 means 0.09, right? 0.1 means 0.01, it is 0, and it is also 0.01. So residual square we have obtained. So from this table we can find RSS, residual sum of square. What is the residual sum of square? Just sum of these. 0.09 plus 0.01 plus 0 plus 0.01. So if we add, then it will be what? 0.11, right? It is 0. So it is residual sum of square. So now then you have to find TSS, right? So to find the TSS, you have to first find the actual average. So what is the actual average? 1.9 plus 2.3 plus 2.6 plus 2.9 divided by 4. So if I calculate it, then what will be 1.9 plus 2.3 plus 2.6 plus 2.9, 9.6 divided by 4. It is 2.425. 2.425. Okay. So now TSS. What is TSS? Total sum of square. So total sum of square means uh, this average ya average minus predicting value, ya average minus predicting value, that is the first one, 2.425 minus 2.2 square plus 2.425 minus 2.4 square plus 2.6 minus 2.425 square plus 2.6 minus 2.8 square. Okay, so this is TSS. So if I calculate, so let's calculate first. 2.425 minus 2.2, sorry, 2.2, this one square. Oh, sorry, 2.425 minus 2.2, this one square. Okay, so I should write somewhere. Okay, just wait. 0.50625, 0.50625. Okay, then 2.425 minus 2.4, 0.025, that's square. 0.000625, 0.000625. Okay, then 2.425, actually 2.425 will be comes first. Okay, again 2.425 minus 2.6. Okay, so I have written one mistake. So this one should be, just wait. This one was 2.425 minus 2.6, and it is 2.425 minus 2.8. Okay, 2.425 minus 2.6, this one square. 0.030625. Okay, then 2.425 minus 2.8, 2.425 minus 2.8 square. 0.140625. Okay, this one equals to should be, so we have to calculate it, right? So you have to make it here. Okay, 0.2225, 0.2225. So in this is specially, this is TSS, right? This is TSS, total sum of square. So we have now RSS and TSS. Just using the formula R square equals to 1 minus RSS by TSS, right? So using this formula, we should find the R square value. So 1 minus, what is R square? It is 1, sorry, what is RSS? It is 0.11, 0.11. And what is TSS? 0.222225. So just calculate it. 0.11 minus divided by 0.225. 0.11 divided by 0.2225. 0.4943. So 1 minus answer. Okay, so first let's write it. So 1 minus 0.4943, right? 4944, okay. 4944. So 1 minus 0.494. 1 minus 0.4944. 5056. 0.5056. 0.5056. So this is your r square. And what is the VIF now? 1 by 1 minus r square. That is 0.5056 square. 1 minus 0.50, sorry, 5056 into 0.5056 square. I have done 1 minus of there, especially answer is not saved. Okay, 0.2555, 0.256. Okay, 1 by 0.256. 1 by 0.256. 1 by 0.256. 3 point. VIF as a 3.9025. Okay, this is VIF. Actually, VIF never be high infinity. VIF is 456 is enough. Okay, so this is VIF model. Okay, so now I have to start the shrinkage problem. Just wait 1 minute. Let's check whether it is recording or not. Yes, it is recording. Shrinkage, shrinkage. It is a method in linear regression that refers to the techniques used to improve models apostrophes, okay, models prediction accuracy by constraining or regularizing the coefficients. Actually, in simple word, I am telling, suppose a model y equals to, suppose I am given 100 x1 plus 250 x2 plus 1883 x3 and so on, very large beta. So these are very large beta, right? So this large beta the um, can cause a problem in estimation. Remember, this large value takes if very small change. Suppose if I make x1 very small change, then y is abruptly changing, right? So actually, what happens? Shrinkage is a technique to reduce this beta value. Okay, the shrinkage specially is a technique to reduce the beta. So these are the beta, right? So very high beta. It is very high beta, right? So this beta should be reduced. This beta should be reduced. So how to reduce? So there are two shrinkage methods. Okay, so there are two shrinkage methods. So first one, rig rig regression. No. First one is Riggs regression, and second one is Lasso regression. So remember, Rig regression sometimes it is called L2 regularization, and Lasso regression sometimes it is called L1 regularization. Okay, so there are two methods of regularization. So you have to learn in your syllabus only rig regression is there. So I am discussing only the rig regression, and I will give one idea about the lasso regression also. Okay, the formula is important, so I will give the formula. Okay, so right, rig regression. So it adds a penalty to the sorry equal to the sum of squared coefficient to the loss function. The penalty term is controlled by lambda, then loss function. Actually, what is a loss function? Suppose I am taking I equals to 1 to n, actual value minus predicting value square, right? So this is basically what? SSE error, sum of square error, right? This is basically sum of square error. This is the loss function already we have used multiple times. And if we add one penalty term to the function of beta square, beta equals to I2, suppose here P. P is the dimension. See, n equals to number of the data points. N number of the data points, and P equals to number of the dimension. Remember, two are different things. Okay. Suppose I have a model. Suppose x1, x2, x3 up to xn and one y. Okay. So these xn are the dimension. So there are n number of dimension. And if we have 1, 2, 3, 4 up to p, so This is the number of data points. These are the p data points. Okay, remember. So these are the data sets. Okay, one row, particular row is a data set. Okay, so for this equation, this is the loss function already we have used, and by using the lasso, sorry, regression, one penalty term will be there, lambda times of beta I square. Okay, so this is the loss function. Basically, loss function is decreased. How to decrease? Because beta is very high value. If beta is very high, so lambda is very small, it is less than 1, basic maybe 0 0.02, 0 0.01, 0 0.0001. So by adding this term to this loss function, basically what, basically the beta is reduced, right? So if I multiply one value, see, suppose beta equals to 200 and lambda equals to your 0.01. So if I multiply these two, then you can find the very small uh, lambda into beta. So lambda into beta square is how much? So for this particular 200 square, that means how much? It is 4000. On lambda, actually you have to predict. Suppose I am taking 0.0001, so 40000 40,000 into 1 by uh, 10,000. So 1 2 3 4, 1 2 3 4. So this term is 4. So this is one of the important concept to reduce the beta high beta value. But remember, lambda is a tunable parameter. Lambda is a tunable parameter. That means we have to tune it as per the requirement. Larger lambda results in largerness, it is should be smaller. Smaller lambda results in greater shrinkage of fitness function or loss function. Remember, shrinkage is important. Shrinkage is important because large beta gives unstable model. Remember, large beta gives unstable model, and beta restricts, sorry, shrinkage rate restricts beta into a lesser value. If beta is high, comma, the model predicts abruptly by changing very small features. That means what? Features means x1 x2, these are okay. So if this x value is small, very little change, then if beta is very high, then the prediction will be abruptly changed, right? Changing. So this is a problem actually, and this problem we can solve using this Riggs regression method. So in rig regression, what is the objective? In rig regression method, L equals to the loss function. Basically, our desire or object is to minimize this loss function. So what is the minimize? How to minimize the loss function? Already we have used, right? 1 to n, suppose this loss function, actually I am writing again, actual minus predicting square plus summation of j equals to 1 to p, or you can write I equals to also, no problem, but here I can write also j, no problem. So this is our objective. So minimize this loss function. Okay, so to minimize this loss function, you have to follow the following steps. First, centering centering the data points. Already we have used, right? Centering the data. Then beta I equals to, beta I means directly you can find the beta directly. Okay, directly you can find the beta using the formula x into x transpose plus lambda into I whole inverse into xy. But remember, I not equals to 0 here. That means for a particular model, suppose the model I am writing y equals to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3. Okay, so I am taking three dimensions only. So there are four betas, 1 2 3 and 4. But this 4 beta, so only for the 3 betas, this beta 1, beta 2 and beta 3 can be found by using these formulas. That's why I am written here beta I, and I not equals to 0. Okay, not equals to 0 means this I name is not for beta naught, and the beta naught should be, according to the Riggs regression method, mean of y. Mean of y. Mean of y. What is mean of y? Actually, mean of y p, predicting. That means 1 by n summation of yp I equals to 1 to n. Okay, so this is basically the beta naught. Beta naught can be directly find using the ypi 1 by n summation of I equals to 1 to n ypi. Okay, so this is basically the Riggs regression method. So you have to first centering the data, then find the beta I, then beta naught. Okay, so here one important concept is how to find the lambda. Remember, if lambda equals to 0, just think about it. If this equation lambda equals to 0, okay, so I have not written the lambda, right? So lambda should be written here, and the first equation should I write lambda or not? Yes, here I have written lambda. Okay, by mistake I forgot to write here lambda. Just write it. So if lambda equals to 0, the Riggs regression is converted into linear regression. Remember, if lambda equals to non-zero small, the beta may be larger to maintain a smaller product. That means if lambda is very small, then beta may be larger, but the product is very small, right? That's why there is a leverage actually. Beta may be larger. For the larger beta, we have used small lambda. So I have just telling it in another manner. If non-zero small, then beta may be larger. Okay, these are also it is also true. But if lambda equals to high, the beta may be very large, very large, for to maintain the same smaller product. Okay, so but here you have to learn something. But small lambda has a tendency, to overfit. Therefore, the choice of lambda should be optimum. The choice of lambda should be optimum, such that model does not overfit, as well as can give a way, can give a low sensitivity to the features. Low sensitivity to the feature means if any feature value is slightly changed, then the prediction is also changed slightly. It is not changed abruptly. Okay, so this is the sensitivity of any feature. But one important term is also you have to learn: lambda never be negative. Lambda never be negative. So how to obtain the lambda? So basically regression is based on the prediction of lambda. Prediction on the choice of lambda depends on choice of lambda. So lambda never be negative, remember. So if lambda is negative, then there will be a problem. So how to find, how to take the lambda? So there is a method. So I'm writing best lambda can be obtained using grid search method. Grid search method. So what is grid search method? Remember, to discuss the grid, to before discussing the grid search method, you have to learn something about its characteristics. Remember, if as lambda increases, remember, training error increases. This line should be remembered, increases. Okay, training error increases, but testing error decreases. Remember, so actually low lambda overfits the model. That means overfitting means what? Training error is very small, but testing error is very high, right? So overfit means what? Already I have told you, na. Overfit means training error is very small, but testing error is very high. So this is the characteristics of overfitting. Actually, overfitting model remembers all the data points. So to so this is the suppose this is the point data points, and model learned all the notion of the data. So after learning in training, see there is no error. Error is very small, but after training phase, when it is going to the training testing phase, then there is a notion. There is no notion to predict. We can move. We can move from, suppose this is a point, and this is another point. So we can move these 3 points by this line already we have written, or by this line, or by this line, or by this line, whatever. But by using several lines, what should be the value of prediction if it is here? So it may be here, it may be here, it may be here, so there is no specific prediction. Okay, so 3 or 4 different values we are predicting if we consider no notion. That means the training phase error. Okay, so in between these there may be one value. It is called a testing phase error. Okay, so remember, if any model overfits, then training error is very small but testing error is very high. So if lambda increases, the training error increases but testing error decreases. Okay, but if we swap the word, that means if lambda decreases, then training error decreases and testing error increases. Okay, so there is a trade-off between training and testing error. So what is the grid search method? Just I am discussing the grid search method here. So grid search method is to take all the lambda. Okay, what is the possible lambda? What is the possible range of lambda? Just user define the range of lambda only. Okay, suppose the range of lambda is very small, that is from 0.0001. Suppose this is a lambda, and this is a value is near to 0.0001, and suppose the maximum value of lambda is 0.2 I have taken. So in between 0.0001 and 0.2 I will consider the lambda. Okay, I will consider uh, the model. So if lambda is very small, so here I am writing error. Okay, here writing error. So it will start from here. So testing error gradually decreases. Testing error gradually decreases, and training error is increases. Training error is increases. So it is training error, and this is testing error. See, as lambda increases, testing error decreases, but training error increases, right? So as lambda decreases, training error decreases, but testing error is high. So what should be the optimum choice of lambda? So to find the optimum lambda, actually we have to take the intersection point between these two. Okay, these two characteristics. So this is the optimum lambda, lambda O, optimum lambda. So this is the grid search concept. So grid search takes a range. It takes a range of lambda from user, then perform every possible model with all lambda values between the ranges. Draw two characteristics: training error, training error, and testing error. These two characteristics. Then find intersection point. Find That's all. So this is the concept of grid search. So for to obtain the optimum lambda, we can do the grid search. This is a conceptually is a very large concept, but program will takes 1 to 2 minutes. Okay. So this is all about your regression. And for lasso regression, just I am writing for the lasso regression. Lasso regression sometimes called L1 regularization. Lasso regression, everything remains same. Just loss function I am writing. Loss function L equals to minimum of summation I equals to 0 to n yai minus ypi square plus lambda into summation of j equals to I to p mod of beta j. Okay, so this is a formula. So initially for the regression we have used beta square, and here we have used only mod of beta. So this is for the lasso, and everything remains same. Okay, so I think it is sufficient. So students, please see this recording and take a note. Okay, at your free time. Okay, today's class is over, so you can, I will share this video within some time.